Compounds containing sp2 carbon bonded to an halogen bond. Okay, this class includes vinyl halides. Actually, in the previous class, in the last two we learned is halidic and benzylic halides. Okay, you remember that. Vinylic halides. What are vinylic halides? These are the compounds in which halogen atom is bonded to sp3 hybridized carbon atom of a carbon-carbon double bond. In the previous allylic halide, we can say that the halogen atom is attached to the sp3 hybridized carbon, but this carbon is attached to the another carbon. That carbon is double bonded. But here what we are learning is here let us take this example. This halogen is directly attached to the carbon which is double bond, which is itself is double bonded. You can clearly look at here also. I will split that. What is there? This is a carbon. Okay, this carbon is attached to the halogen. Here we can find double bond. This halogen is attached to this carbon, right? But this carbon is an double bonded carbon, that is sp2 hybridized carbon, that is given in the definition. Okay, let us read the definitions once more and clear about the definition, and we can get one more also. These are the compounds in which halogen atom is bonded to an sp2 hybridized carbon atom of a carbon-carbon double bond. Okay, these are the compounds in which halogen atom is bonded to sp2 hybridized carbon atom of a carbon-carbon double bond. Okay, clear with this. Next is aryl halides. Yes, this is the same classification, but for as I told, in halohalkanes and haloarenes are studying simultaneously. So halohalkanes and haloarenes are studying simultaneously. They are classified as both A and B. Okay, but the classification is same, that is containing sp2 carbon to halogen atom. Okay, aryl halides. These are the compounds in which halogen atom is bonded to sp3 hybridized carbon atom of an aromatic ring. Here we can observe that aryl halides are the compounds in which halogen atom is bonded to sp2 hybridized carbon. Okay, this is sp2 hybridized carbon, but this sp2 hybridized carbon is included in aromatic ring like this. If it is included in this aromatic ring, then only we can say that this is an aryl halide. Okay, are you clear with this? Aryl halides are the compounds in which halogen atom is bonded to sp3 hybridized carbon atom, but that carbon atom should be included in that aromatic ring. These are the examples. Here you can find it. Here carbon is actually double bonded, and also it is included in the aromatic ring, that is benzene. Here also halogen is attached to the carbon atom. This carbon is sp2. Yes, this is carbon sp2 hybridized. Is this carbon is surrounded is this included in aromatic ring? Yes, it is included. Then it is called as aryl halide. Okay, it is completed. Okay, nomenclature. Actually, we have learned about nomenclature in the previous year, first PO also. Okay, but now learn the nomenclature of this. Having learned the classification of halogenated compound, let us now learn how these are named. Yes, how can we name these halogen atoms? Haloalkenes, haloarenes should be known in this nomenclature. The common names of an alkyl halides are derived by naming an alkyl group followed by halide. Yes, common names of an alkyl halide are derived by naming an alkyl group followed by halide. Example, if this is the example, how many carbons? 3 carbons. Prop. What is the single bond? What is called as for that we can call it as propyl. For that, what we called it, like if we remove one of the carbon, what we call it is called as methyl. Like that we called as propyl. Okay, then it is followed by halide. Propyl, if it is chlorine, propyl fluoride. Halide, this is an halide, this is an alkyl. This is the one of the common naming factor. naming an alkyl group followed by halide. Alkyl halides are named as halo-substituted hydrocarbons in the IUPAC name system of nomenclature. But in the IUPAC system of nomenclature, we call it as chloropropene. Okay, propane. There is no double bond, so it is called as chloropropane. Okay, haloarenes are the common as well as the IUPAC name of aryl halides. Haloarenes are the common as well as IUPAC. Both are the possible. It is common name also, IUPAC name also. It is for only aryl halides, not for alkyl halides. In alkyl halides, common names we can name it as alkyl halides, but IUPAC name is called as halo substituted hydrocarbons. Okay. For dihalogen derivative, the prefix OMP, that is ortho, meta, para, are used in common system, but in IUPAC system the numerical 1, 2, 1, 3, 1, 4 are used. Yes, I will tell you that. If this is the situation, when it is attached to halogen, this place is called as ortho, meta, para. The one thing you have to remember for this, remember, is OTP. Okay, first thing is O, second thing is third thing is P, and the middle thing is T, but we can replace because we after removing O and P there is only meta position, so remembering the formula is OTP. Okay, ortho, meta, para are used, but in IUPAC system, IUPAC system, this is called as 1, 2, third position, like that. This is if it is attached to halogen, then this is the one first position, second position, third position, and fourth position. If here in some of the chlorine is attached, then it is called as, here also chlorine is attached, 1, 4 dichloro, and then remaining name continues. Yes. In IUPAC we can use the numbers. It is clear to all. Let us look at for some of the example. First thing is, how many carbon atom is there? 3. That is prop. Here propyl, common name is actually already know that alkyl halide, right? Like that, alkyl, propyl, halide, which is the halogen? Bromine. So bromide. What is the IUPAC name? IUPAC name is bromopropane. In this IUPAC name we should have to mention the position name, bromopropane. Okay, here the same number of carbon atoms is there, but the halogen is different and the position attached is also different. So in IUPAC name it is called as, it is attached to the second position, so it is called as 2-chloropropane, but in common name we call it as isopropyl chloride. Okay, isopropyl chloride. It is, and the next example is isobutyl chloride. Yes, isobutyl chloride. Here 4 carbon atoms is there. We can consider butyl chloride for the halogen attached here. We considering this as iso, but the IUPAC name is 1-chloro 2-methyl propane. Why is we consider the chlorine first preparation? In that series we can learn about that chlorine should be get first preference, then methyl. So 1-chloro 2-methyl propane. Okay, that is the IUPAC naming. I think if you are confused, 1 minute. Yes, it's recording. I think if you are confused with how can we name the common name, here iso is taken, here iso is taken, here N is taken. If you are doubt with that, I have reference for that. Let's check this image. Wait. Okay, for this for your reference I have given this image. We can actually make a difference in here. Yes, we can consider N when it is a straight chain, anything halogen, anything attached to the straight chain. but we call it as secant when halogen or any other R group attached to the second or third. It means if a number from here it become to second place, then it is called secant. But what is the difference between secant and iso? Yes, here carbon is only attached to the second position. Did you find that? Yes, carbon is attached to the second position, but here chlorine or any other different alcohol or any other attached to the second, then it is called secant. If it is T, it looks like T shape. Actually can make a difference at all. So if it is in T shape, then it is tetra. Okay, let us come to the lesson. You may find the difference in here. Okay, let us continue. Here bromo is attached to the benzene, so it is called as a bromobenzene. No different at all. Actually I said that a common name and IUPACs are same for aryl halides. Okay, next here ortho position, meta position. So meta dibromobenzene. Okay, here this is ortho position, meta position. This is also meta position, right? Sim tribromobenzene. Okay, sim tribromobenzene. The IUPACs names are very simple actually. Then common names. Here 1, 3, 5 are the position, and how many halogens? Try 3. And what is that halogen name? Bromo. What is this aromatic ring? Benzene. Same here also 1, 3 is the number. What is the halogen? How many are there? 2 di. And what is that halogen? Bromo. And what is that aromatic ring? Benzene. Okay, same here bromobenzene. It's clear that. Next we consider this. I think it looks like some complicated, but it is easy. Let us consider from here. Here, what is the position of bromine? Second position. Write the position second. Is there any 1 or 2? Only 1 is there, so no need to write di or tri or mono. Next, what is the halogen? Bromo, right? And what is this alkyl name? 1, 2, 3. 3 carbons are there. Propyl. Why? Because one of the carbon is removed, so it is called as propyl. 1 bromo, but in IUPAC name we can write the alkyl name. So propane. Clear with that? Let's check it that. Yes, 2 bromo propane. We got that answer same. Let's do this also. Let's slash this name. Okay. Chlorine is attached to this. Okay. Now we have to consider the chlorine, and actually position number is 1, so 1 is not necessary. Chloro, that halogen name is chlorine, so chloro. And what is this name? We have to find out this name. Okay, what is the shape? I actually told that when it is plus, let's put T and name it. This is for common name, not for IUPAC. Sorry, I found wrong. Actually IUPAC should be name. There is no common name given, so I am not giving common name for you. Okay, let's slash this. Okay, long chain we have to be selected. This is the long chain. Okay, we have to make that chlorine as the number 1 position. So, and what are the substitution? At second position there is 2 methane are substituted. Okay, First we have to preference for chloro, that is 1 chloro 2 dimethyl propane. Is this correct? Let's remember this name. So 1 chloro dimethyl propane, 1 chloro dimethyl propane, 1 chloro, sorry, 2 I mentioned, but I need to mention the two times. Sorry for that. That is the thing, I forgot how to mention that. Okay, let's read this. The dihalohalkanes having the same type of halogen atoms are named as alkylidine, alkylene dihalide. The dihalo compounds having same type of okay, let us consider break up this statement. The dihalohalkanes having same type of halogen atoms are named as alkylidine or alkylene dihalide. Okay, if example, okay, this is not a better way, I will give in the simple way. Here you find that dihaloalkanes, two haloalkanes having same type, that is chloro are named as either what we call what we can name this as dialkyl. What is alkyl? Propylidine. Okay, or else we can name it as propylene dichloride. Okay, are you clear with that? We have to remember these names only: alkylidine and alkylene dihalide. The dihalo compounds having same type of halogen atoms are further classified as geminal halide halogen atoms present on the same carbon atom and vicinal halide halogen atom present on the adjacent carbon atoms. In common name, gem dihalide are named as alkylidine halides and vicinal dihalides are named as alkylene dihalides. Okay, actually I don't understand that. I will show with an example. If the halogen is attached to the same carbon, dihalogen atom only, not tri or tetra, then it is called as geminal halide. Here halogen is attached to the same carbon, but if it is attached like this, then this is called as vicinal dihalide. Okay, vicinal halide. I think you are clear with it. Common name. Yes, here is the example, so I didn't observe that. Common name: gem halide, vis halide. Yes, we found that vicinal dihalide, it means the chlorine are attached to the two carbons. Yes, we differentiated the geminal halide and vicinal halide. In this vicinal halide, this chlorine atoms or halogen atoms is attached to two different carbons, but in geminal halide, the carbon two carbons is attached to the same carbon. Then it is called geminal halide. When it is attached to different carbon, it is called as vicinal halide. So we already learned about the EPAC naming the numbers. We can find out. Okay. Yes, we come to the 10.3 exercise, that is nature of carbon and halogen bond. Yes, since halogen atoms are more electronegative than carbon, the carbon halogen bond of an alkyl halide is polarized. The carbon atom bears a partial positive charge, whereas the halogen atom bears a partial negative charge. Actually, this statement is understood. Yes, halogen atom is electron seeking. It always ready to take one electron to complete it octet. when it is when the electronegativity it is compared, halogen atom is more electronegative than the carbon atom. So there is a polarization occurs. Carbon gets partial positive charge and halogen gets partial negative charge. Okay. Since the size of halogen atom increases as we go down to the group in the periodic table, fluorine atom is the smallest and iodine atom. Since the size of the halogen atom increases as we go down the group in periodic table, fluorine atom is the smallest and iodine atom the large and iodine atom the largest. Consequently, the carbon halogen bond length also increases from CF to Ci. Some typical bond lengths and bond enthalpies and dipole moments are given in table 10.2. Yes, carbon fluorine. As we go down, fluorine, fluorine, bromine, chlorine, bromine, iodine, the atomic size also increases and also the bond length also increases. You can look at here, the bond length also increasing. Okay, that's the thing. We are using some typical bond lengths and bond enthalpies and dipoles are given in table 10.2. Consequently, the carbon halogen bond length also increases. Okay, we are moving to next. We are arrived at the 10.4, that is methods of preparation. This is the one of the most important exercise for NEET JEE and also for board exam. Until then what we learned is not so very important for anything, but from now it is very important. You need to understand carefully every point. Okay, methods of preparation from alcohols. Alkyl halides are best prepared from alcohols which are easily accessible. Yes, alkyl halides are best prepared from alcohols. This is one of the remembering statement which are easily accessible. The hydroxyl group of an alcohol is replaced by hydrogen. Yes, let us take that. This is the hydroxyl group. This hydroxyl group is replaced by halogen on reaction with concentrated halogen acid. With concentration halogen acid, phosphorus halides or thionyl chloride is preferred. Thionyl chloride is preferred because the other two products are escapable gas. Hence, the reaction gives pure alkyl halide. But thionyl chloride is the preferred because the other two products are escapable gases. The reaction gives pure alkyl halides. Okay, phosphorus tribromide and triodide are usually generated in C2, produced in the reaction mixture by the reaction of red phosphorus with bromine and iodine respectively. The preparation of actually I will learn we can learn about this in the next chapter. Okay, next part.